Hey guys, we're going to start Unit 8 today, which is graphing linear inequalities. Um, this is kind of similar to when graphing equations and graphing inequalities. Or, yeah, just on like a number line. Same kind of concepts you're going to be seeing. It's going to be a little bit more challenging because this is our first new lesson on this completely online platform. So it's going to be a little bit weird. So ask me any questions that you need to via email, message, any other way that you want to contact me, okay? So I know I skipped that slide, but I did it on purpose. So here's a couple of things that you need to know. If it says less than or equal to or greater than or equal to, you're going to need to graph a solid line. So that's kind of like, remember when we had open and closed circles? It was a closed circle if it had a line underneath it. Now it's a solid line. Similar to that also, if it doesn't have a line under it, if it's just less than or greater than, you're going to have a dotted line. The reason behind behind this is because if it is less than or equal to or greater than or equal to, the line is included in your solution. That means that if you take an ordered pair that's on the line and stick it back into your equation, it's going to give you a true statement, okay? It's a dotted or a dashed line if it's less than or greater than, because if you were to stick a number that's on there, it's going to be false, okay? I have a better kind of visual for this on the next slide, but if it's less than or equal to, you're going to shade below the line. Or if it's less than, you're going to shade below the line. And if it's greater than or equal to or greater than, you're shading above the line. And there's a very, very easy way to see this. So again, this is just, for example, if it's less than, it's a dashed line shaded underneath. Less than or equal to, solid line shaded underneath. Greater than, dashed line shaded above. Greater than or equal to, solid line, because there's a line underneath it, and shaded above. All right. Now, if it's less than or equal to, you're going to shade under your hand. If you don't know what above or below means, you're going to take your hand and you're going to put it on the line. Okay? So here's my hand. It's not exactly on the line because I just want you to see what you should be doing. So my hand would be on top of this line. And you just have to think to yourself, where is underneath my hand? So obviously this is underneath my hand. This is the palm of my hand. And so I would shade all this underneath this line. Okay. If it's greater than or equal to, you're going to put your hand over top of the line. And then you're shading above your hand. So this is above my hand or at the top of my hand. And I'm shading in all above that. Okay, so what this basically is doing is all of these answers are a solution, will be a solution. So if you pick any ordered pair and stick it into your equation, you're going to get a true statement similar to this. Okay, so if you don't know where above or below the line is, you take your hand, put it over top of the line, whether it has a negative slope or a positive slope, and you follow the inequality. If it's less than, you're shading below your hand. If this was greater than, you'd be shading above it. Okay? If it's, so we're above it here because it's greater than, but if this was less than, we'd be shading all down here. All right, you'll see what I mean. The only exception to that rule is when we have x by itself. Okay? So these rules apply when you have an equation in y equals mx plus b form. If you only have an x, and that's very, very rare, you are shading where the arrow is pointing. Okay? So remember back in Unit 6 when we had x equals or y equals to the line, if you only have an x, the graph of your line is a vertical one. If you only have a y, the graph of your line is a horizontal one. what I like to do when I'm graphing these inequalities, I have to remember if it's going to be solid or dashed. I need to remember to either make my line solid or make my line dashed. So in order for me to do that, I take my pencil or my pen and I box it in. If it's solid, it's going to be a solid box. Oh, sorry. However, if it is less than or greater than without a line underneath it, that's going to be a dashed box. So I'm going to box this in with a dashed box. So you don't have to do this. This is just so I remember to make my line dashed and to make my line solid. So these graphs are pretty simple. So x is greater than or equal to 4. So you have to find where x is equal to 4. So here's your x-axis. X is equal to 4 at 1, 2, 3, 4. So you place your dot there. I don't know, could you see that? I'm not done. Okay, and then you're going to put your solid line, of your vertical solid line, right there. I'm not done. Shh. So a solid line everywhere that x is equal to 4. So there's my line. It's solid, but I don't have any shading done. So the only time it tells me where to shade is when x is by itself. So it's telling me to shade this way. So I'm going to take my highlighter and shade everything to the right of 4. Okay. And basically this means is that x is bigger than 4. So all of these x's over here are bigger than 4. Color up. This x right here is 6. So if I were to substitute this in here, 6 is greater than or equal to 4. That's true. Okay, so everything that we graphed here would be a true statement. If I picked this point right here, x is 0, 0 is greater than or equal to 4. That's not true. Therefore, we don't have it shaded in. Okay. We're going to do the similar thing with this. So it's y is less than 0. So here's your y-axis. When you're graphing only a y, your graph is going to be horizontal. So I find where y is equal to 0, which is right here. Okay. You're making a horizontal line at that point, and it's a dashed horizontal line. So it actually goes right over top of this x-axis. Okay. Now either take your right or your left hand and put it right over top of this line. So if you take your left hand, the top of your hand is facing up, bottom of your hand is facing down. If it's less than, you're shading underneath your hand. So underneath your hand is all down here. And this should make sense because all of these points down here are less than 0. So if you were to pick a y value down here, say this one, which is -2, -2 is less than 0. That's true. Okay. If you were to pick a point up here, say this point, 1, 2, 3, 4, 5. So if you were to pick 5, 5 is not less than 0, therefore it's not a part of my shaded region or on my graph. Alright, so they were easier. Here's just a scenario. It's just asking if the ordered pair is a solution. So your ordered pair is right here, -4, 3. So -4 is our x value, and 3 is our y value. So they want to know if -4, 3 is a part of our shaded area or not. So all you have to do is you take these numbers and you substitute them in for x and y. So instead of y, I'm going to write 3 is greater than 2 over 3 times, instead of x, I'm writing negative 4. So you have 3. If you were to put that in your calculator, you're going to get negative 8 over 3. 3. And, or in your brain, I'm sorry. So 3 is greater than or equal to 1/3. And that's true. If it gives you a true statement, then yes, it is a solution. Oops. Why do I keep on hitting that? This point would be in the shaded region because it gives me a true statement. All right, let's graph. So we're given an inequality. This needs to be in the form y equals mx plus b in order for us to be able to graph it. So it's a less than symbol, so I'm going to box this in with a dashed box because I don't want to forget what kind of a line I'm going to be drawing. So when I connect my dots, I'm going to have a dashed line. I'm sorry that it's taking a while. Okay. It's hard to do it with a mouse and not be writing. All you have to do is you have to figure out what your slope is and your y-intercept and graph them. So your slope here is 4 over 1 and your y-intercept is negative 5. So 4 is positive, so you're going to go up and you go to the right. Also remember you could do the opposite, so I could also go down and to the left. Okay. All right. So we're graphing these. So you begin at your B at negative 5. 1, 2, 3, 4, 5. Wait, 1, 2, 3, 4, 5. Put your first point there. And then you go up 4. 1, 2, 3, 4, and to the right 1. Or I could go down 4. 1, 2, 3, 4, and to the left 1. I'm going to connect these 2 points with a dashed line. Or these 3 points, I'm sorry. To form my line. Extending it. Okay. Now, you're going to put your hand over the line. Okay. It is less than. So less than means I shade under my line. So put your left hand on top of that. You're shading underneath your hand. So if you have your left hand on top of the line, underneath your hand is this area down here. Okay. So I'm shading in all of this. All of this is underneath your palm right now. And that's how we graph linear inequalities. I'll show you more examples in the next video, but this is going to cut me off at 15 minutes. Oops, sorry.